Okay, so in lesson 2, we're going to expand our understanding of angle bisectors and perpendicular bisectors by applying them to specific situations in triangles. So first, you should have the vocabulary done from those flashcards I posted in Classroom. So we're going to start off with the definition of something called the circumcenter of a triangle. Okay, circumcenter theorem. The circumcenter of a triangle is formed by the perpendicular bisectors of the sides of the triangle. So I want you to focus in on the triangle to the right. PD is a perpendicular bisector to AB. So PD is perpendicular to AB, and it is a bisector of AB. So I'm going to draw that to show that that's a perpendicular bisector. PE is another perpendicular bisector. It is perpendicular to BC. It splits BC into two congruent parts. PF is a perpendicular bisector. PF is perpendicular to AC. It splits AC into two congruent parts. So that means that P is the circumcenter of ABC, triangle ABC, sorry. Okay? The big thing that I want us to understand from all this is that it is formed by those perpendicular bisectors. The other piece of important information is that PA, PB, and PC are all the same length. It is equidistant from the vertices of the triangle, meaning it is the same distance from each vertex of the triangle. That is the main characteristic of the circumcenter of a triangle. We are going to get practice on this. You are going to have to reference your notes to remember the difference between circumcenter and incenter, which is what I cover after this. So an example of finding the circumcenter of a triangle, well, first you're going to have to graph that triangle on this coordinate grid. So 0, 3 is point A, 0, negative 1 is point B, 6, negative 1 is point C. And I'm going to connect those points with segments. That was a bad one. So, to find the circumcenter, I have to do a few things. Number one, I have to find the midpoints of all the sides. Second, I have to draw a perpendicular through at least two midpoints. Okay. 3, I have to find the intersection of those perpendiculars. So kind of a checklist. And you're going to see that it's not quite as hard as it seems to find that circumcenter. So first I'm going to find the midpoint of AB. And if I look at AB, it is 1, 2, 3, 4 units long. So its midpoint is going to fall 2 units between A and B. So its midpoint is right here. Okay, that's the midpoint of AB. That's the easiest one to find because it's a vertical line. I can just count the boxes, or I can count the units. For BC, it is 6 units long, so its midpoint is 3 units to the middle. So that's easy enough to find those midpoints. I want to draw perpendicular to AB through that midpoint of AB. So we look at AB. AB is a vertical segment. A perpendicular to a vertical segment is a horizontal segment. Got a little wonky there at the end. I look at BC. Perpendicular to a horizontal segment is a vertical segment. Now, if I was drawing actual straight lines, you'd be able to see that those all intersect. Those two perpendiculars intersect at a point. And that point is 1, 2, 3, 4 units long. So its midpoint is 3 units to the middle. So that's easy enough to find those midpoints. I want to draw perpendicular to a vertical segment. So we look at AB. AB is a vertical segment. A perpendicular to a horizontal segment is a vertical segment. Now, if I was drawing actual straight lines, you'd be able to see that those all intersect. Those two perpendiculars intersect at a point. is the circumcenter. Oops, I'll do a better job of that. Circumcenter. That is the point 3,1. It is the intersection of the perpendicular bisectors of that triangle, okay, of the sides of that triangle. Now, the main thing I want you to remember is that what we just talked about, we'll make this point D, okay? Point D is the same distance from all the vertices of the triangle. So that means that AD is equal to BD is equal to CD. It's equal distance from all the vertices of that triangle, all the points that make up the vertices of that triangle. Okay, so finding the circle. Next, I want you to do a little bit of practice with this. So pause the video, wait a few seconds, work through it, resume the video when you're ready to check your answers, and then I'll go through the last example. So for part 1, the circumcenter is at -4, +2. For number 2, circumcenter is at 0, -1. So finding midpoints and finding perpendiculars to vertical and horizontal segments. The last part of this lesson, we talk about a different type of center. This is the in-center. And this is another important thing to determine, is that the in-center is formed, or it is the intersection of the angle bisectors of a triangle. Okay, so it's formed by PA being an angle bisector of angle A, PB being an angle bisector of B, and then PC being an angle bisector of C. So it's formed by the angle bisectors, all right? The important part of this is that the in-center is the same distance from all 3 sides. So from P to side AB is the same distance from P to side AC. It's the same as the distance from P to side BC. PD, PE, and PF are the same length. So the in-center is the same distance from all 3 sides. So the main distinction, circumcenter, is formed by the perpendicular bisectors. It is the same distance from all 3 vertices. The in-center is formed by the angle bisectors of the triangle. It is the same distance from all 3 sides. So in example 3, when we look at this diagram, we just covered in-center, so you know it's the in-center. But what I want to illustrate is that B has an angle bisector, A has an angle bisector, C has an angle bisector. So that's what tips us off to this being, to N being the in-center. So what that means is that ND is equal to NE, and that's equal to NF. N is the same distance from all 3 sides. So all of those lengths are the same length. So what I can say is that since ND is congruent to NE or equal to ND, or ND and NE are congruent, I can say that 5x minus 1 equals 2x plus 11. So to solve this, I can subtract 2x from both sides to get 3x minus 1 equals 11. Add 1 to both sides to get 3x equals 12. That makes x equal to 4. The nice thing about this type of problem, I now substitute 4 back into an expression to find out what NF is. And really, I can just do either expression. I could do ND, 5 times 4 minus 1 is 19, or NE, 2 times 4 plus 11. Either way, knowing that all of those are congruent, I get that NF is 19. This is a good way to check your answer, because ND and NE have to be the same length. If you get a value that makes them different lengths, you know you went wrong somewhere, okay? A follow-up to this, NG, the segment NG. I'm gonna highlight that in red, or sorry, blue. I'm going to do it in blue, a little bit more distinct than the diagram here. NG. Can NG be 18? Flat out, no, it cannot be 18. NG must be shorter than NF. The reason being, NF is the shortest distance to AC. Remember, the shortest distance between a point and a line or a line segment is a perpendicular. So NF is the shortest distance between N and AC. So a final guided practice, same example as before, just different numbers. I'm just going to start you off by just illustrating that Q is the in-center, means it's formed by the angle bisector, so we can assume that QP is equal to QN is equal to QM. So take a second to check that out, work through it, and then when you're ready, check your answers with me. That'll be the last example. So I'm just going to flash the answer on the screen and then end the video shortly after. So in the end, QP is 12.5. So this just illustrates that you don't have to be concerned if you get a decimal. Substitute into both expressions. If they're equivalent after you substitute, you know you did it right. So you're ready for the practice on this. Take your time, reference your notes, make sure you know the difference between a circumcenter and an in-center.